All right, in this presentation we will talk about programming a quadSolver that will solve a quadratic equation. So I also have a runner. It says given the values a, b, and c of a quadratic equation ax squared plus bx plus c equals 0, solve for the roots of the equation. And we're going to learn about if, and else. And these are control statements. They are controlling the flow of the program. All right, so to begin with, we have public class quadSolver, and I have saved this as quadsolver.java. And I'm going to have instance variables, and in this case I've decided to declare them all doubles. I'm going to have a, b, and c, which are the coefficients of the quadratic equation, and then I have another one called dis for the discriminant, basically because I don't want to type all of that all of the time. We have the instance variables that are declared private. They are doubles, a, b, c, discriminant. I'm actually going to add in roots 1 and 2 so I can use them whenever I need them. All right, so my constructor takes a double P1, a double P2, and a double P3. And we're going to take P1 and put it in for A, P2 put it in for B, and P3 and put it in for C. These can be anything you want. Just remember that if you use A, B, and C, you've got to change this slightly. And I'll come back and talk about that in the end. And then I do the calculation of the discriminant. So the discriminant is going to be b squared minus 4ac. And we're going to use that to determine how many real roots we have. So I'm going to simply start this by telling you how many real roots we get for each possibility. So I'm going to have a public, and I'm going to return a string. That's going to be text, and we'll talk about that in a second. And it's called roots. If my discriminant is less than 0, that means that I would try and take the square root of a negative number. There will be no real roots, and I'm not going to make any change to that. If the discriminant equals 0, then I have minus b plus or minus 0 over 2a, so there would only be one real root. And if it's positive, greater than 0, then there will be 2 real roots. Now, notice that I am returning a string, which is text, and this is the string I'm going to return in each case. So if I click on this, you'll notice it takes me up to, and so it's including all of the method. With an if statement, I have if, open parenthesis, I have a Boolean expression inside the parentheses. This statement will be either true or false. And so depending on what the values of those coefficients are, the discriminant will be less than 0, equal to 0, or greater than 0. So this will be either true or false. If it is true, I print this out. If this statement is false, I skip it completely and come to the next if. And this should be, if I had done this correctly, should be else if. All right, so if that failed, I come down and say, does it equal 0? Is the value of the discriminant the same as 0? If it is, there's going to be the one root. And then finally, the only thing left is that there are 2. Okay? Now, I have put everything, in each case, I put these guys inside of braces. When I have only one statement, I don't have to, but I'm going to want to before this is all over with. All right, so let us calculate what the value of the roots are. In the case of one real root, what I'm going to do is root 1, there we go. Now, I don't have to give it a type because I've already declared it, up here as a double. So that's not a problem. Now, if the discriminant is 0, then this is going to be equal to minus b, and let's make this minus 1 times b just to exaggerate it, and we'll make this 1.0 since we're dealing in doubles. And we're going to divide this by 2 times a. And again, moving this out, for completeness, we'll call that 2.0, and we'll put in a semicolon. All right, so that gives me the value of the one root. And so what I can do is concatenate, and let's see, there is one root, and all right, so this will then spit out the value of the root. Okay, so let's test our first two. Let's go to the quadSolver, and I very nicely tell you if I use 1, 4, 1, I get 2 roots. If I use 1, 8, 16, I will have 1 real root, and if I have 1, 1, 1, I will have no real roots. And so I go here and say quadSolver Q1 equals new quadSolver, and I used 1, 1, 1. And now I say why I said dis, I'm not real sure, because this is actually going to give me the answer. Q1.roots, and then I print that out. So if I save that, and let's see if we typed everything, we did. And now we run this, and sure enough, there are no real roots. So I was correct with this. So now I want to change this to 1, 8, and 16. And it tells me that there is one real root and its value is minus 4. Okay, so let's go back and finish this. So now I'm going to have root 1 equals minus 1 times b plus math.sqrt of dis. Now, I need to divide that by 4ac, and since this is a sum, I need to put this in parentheses, and then divide this by 2 times a. And because I'm somewhat paranoid about this, I'm going to put that in parentheses as well. And a semicolon. Now, root, I'm having a tough time with root here, equals. And all I'm going to do is copy this whole thing. And now I'm going to make this minus. And first root is. All right. So now this is going to read somewhat the same. There are 2 real roots. The first root is root 1. The second root is root 2. And so we're going to save that, and we're going to compile it and make sure I didn't mess up. And now I want to put in 1, 4, 1. So we'll back that up, and we'll put in a 4. We'll compile this, and we'll run it. So it says there are 2 real roots. The first root is, and the second root is. Okay? So the point of this, there are a couple of points to be made here. I've declared a group of instance variables. I declared them all to be double so I can put them all in a row and separate them by commas. It's simply a space-saving technique. And I only give 3 of them values, A, B, and C, get the value P1, P2, and P3 that are getting passed in. And inside my constructor, I calculate a value for the discriminant. And I do that so that it is pre-calculated and I get to now use it anywhere I want to. The values root 1 and root 2, as you saw, will be used later, but they've been predefined as doubles, so I don't have to, in the method, declare those variables. So my public string roots, string is my return type. It is the text that's being returned. And now I have my first of the control statements. If the discriminant is less than 0, there are no real roots. And then I say else if the discriminant equals 0, in other words, the discriminant has a value of 0, it's only going to have one real root, and it is minus 1 times b divided by 2a. And now I print out there is one real root, and its value is root 1. And finally, I say else because there is only one case left, and that is that the discriminant is positive greater than 0. So I have to define root 1 and root 2, and we've decided that root 1 is going to be minus 1 times b plus the square root of the discriminant, and that whole thing divided by 2a. And then from root 1 to root 2, I change it from a plus to a minus. And then it writes out there are two real roots. The first is and the second is. And we get all of that. So we have a new way of looking at instance variables. They don't have to be just sent in. I can use values and calculate what the discriminant will be in each case. And then I'm going to use it down in here. Now, please notice that if I try to take this and x, if I try and do that, and I compile this, compile and run, notice that I've got problems. It says I've got one real root, and this is the one that should have two real roots. I knew I was going to have a problem because I've defined this up here before I know what the values of a, b, and c are. So I want to take this out, put it back, there we go, put it back in there, save it, and recompile and run. Okay, that makes more sense. Why would I have gotten a strange answer with this up here? Well, by declaring discriminant up here and then taking a, b, and c, everything is 0, so discriminant becomes 0. And so I'm going to have this guy, and it's going to be minus 1 times b. Well, if you remember, b was going to be 4, divided by 2 times a, which is 1. So negative 4 divided by 2 should be negative 2. So let's do it the easy way. I can hack that out, which is going to have the same effect. And so I get negative 2, which is what I got before. So what is the point that I'm trying to make? I can't use a, b, and c in my calculation until my constructor has given them values that I pass in. Otherwise, it's going to be 0 and totally useless. All right, that is my quadSolver, and it is getting the value, or it is getting the roots of a quadratic equation.